It's really nice to be back. We've been here, as I mentioned before, 2 years ago at the Adaptive Architecture Conference organized by Mike Stacey, and the building was already under construction then, but the kinetic facade was still a promise we were presenting here. And actually at that time, the fabrication process, the prototyping process, and the programming had not started. And it was really tricky for us to present it. And so now I'm really, I feel really the happiness that I can now present the finished building. So let me just briefly introduce SOMA. We have 4 partners, 4 founding partners, 3 of us are on the image here. Martin Oberschau and Stefan Rutzinger. Günther Weber is the 4th one of us. We are based in Austria. We have 2 offices in Vienna and 1 in Salzburg. And SOMA, for us, has a double meaning. On one hand, the body, the sentient body, is of course always in the center of architecture. On the other side, we really like to understand architecture itself as a body that's potentially mutant and transformable. And in case of the theme pavilion, as we would say it, breathes. I would like to start and give you a brief introduction on the building itself, on the architecture. We won this competition, this open international competition in 2009. We did not really expect to win it. It was partly invited. Zaha Hadid, Vinimar, Shigeru Ban were in the competition. 1,000 participants registered. So winning this was really an amazing thing for us. And here the building is already there at the Expo opening on Expo Plaza. The brief of the competition was very vague. Basically, the organization, the Korean organizers, wanted to have a building that would symbolize the theme, the living ocean and coast. And it was not at all our intention to do anything that would be an icon or a symbol, but we rather were thinking of how can we embed the Expo's agenda into the architecture, how can we develop a climate concept, and then later on how to develop a biomimetic approach for the kinetic facade. So we were really interested in turning the theme of the Expo into a multi-layered architectural experience. So here's the site. Yosu is a 300,000 city in the very south of South Korea. This is all in here's the city, and this is all an industrial harbor that has been turned into this Expo site. Here you see a site plan. So the position alone of the building designates it as the main landmark of the Expo. It's exposed to all sides, so it was pretty clear to us that we would have to develop a building that really has different faces to all the sites and would have different appearances. And then, of course, to us it seemed to be very crucial to work with this ocean coast here that was overwritten already by the industrial power and that now was in the process of being overwritten again by the Expo. Just for us, really interesting that in the end the building gets indeed a hybrid between landscape and building when you look in Google Earth and you can't really tell what's the building and what's the topography. So as mentioned before, dealing with the coastline was the main concept for the building. So the idea was to take the exhibition spaces, or at that time there were 6 sub-themes of the Expo, and aggregate it along the industrial coast. And then by transforming it in an interdependent grid, create public zones for the foyer and extend the promenade into the building. So this is this view, the aggregated exhibition cones along the seaside. And the choice of material was also due to the constraints of the site. Since it's built into open water, we had to protect the building from the impact of ocean waves. And so this is where these compactness come from. And then as a counter pole to this, we had this idea of opening it up again with these triangular patterns. Also to enable an after use, since, as you might have recognized now, this is a permanent building. Nobody builds a temporary Expo pavilion out of concrete, I hope. So as mentioned before, these different appearances, so what's compact and solid towards the sea opens up towards the Expo site, and here the building shows this more fragile kinetic facade towards the entrance of the Expo and the background. And when you deal with these different phases, of course, it's a question how to merge them. So here you see how these concrete cones twist into the facade, aluminium facade, and then the GFRP plates. So this idea of the twisting cones was also a very initial concept during competition. It had also to do with the idea of how you experience the ocean, so that you would immerse into the bottomless pit. So the theme exhibitions would all be in these vertical spaces you would literally immerse into, and then on the other side you would also experience it as this horizontal surface. So the other so-called best practice area exhibition would take place on this horizontal platform. And the cones would do this in one movement, and thereby creating, defining and dividing all major spaces in the building. Just what we regularly do in the office, we work digitally of course, but we like to build and prove our ideas in models very quickly. And then just to show again the idea, extending the promenade into the building, creating a shaded space for queuing people. Of course you can't have enough shaded space at Expos, the queues were longer than that. Then the big open foyer, and then you enter into the commons, pre-show, main show and post-show, and then you go up to the best practice area level. So here you see how people were entering and exiting these spaces between those curved walls and diving into these vertical vessels. The foyer open space to contain crowds of people, and in section you see again the idea of the cones that then turn into this kinetic facade and into the roof, and in section the sequence of the spaces. Quite a challenge for the structural engineer was this main cone. Originally in the competition we had these 6 sub-themes, the 6 smaller cones. Later on during the planning we had to insert this main cone to react into the ideas of the exhibition planner. 30 meters in diameter, 20 meters in height. So this was really a big challenge. And as you can see on the right hand side, this is early construction, but everything started almost at the same time. They were doing steel work when the concrete was not even poured yet. So considering that we had 6 months of planning and 18 months of construction, this were very exciting 2 years. So again, parametric modeling is our everyday business. Finding out how many sizes of these triangulated windows we would need to create these patterns with a gradient, and then of course, because we wanted to reuse them, and then here the windows again all closed during Expo, because they're mainly for the outer use of the building. The only windows that were open in the cafeteria. What we added to the brief was the idea of a third exhibition zone, a freely accessible open roof garden that everybody could access, and where there would be no queuing lines. So you walk up through on this meandering path through and in between the cones, and the cones frame the view onto the surrounding and the ocean. And this actually became a very popular space during afternoon hours, and also then at the evening it was an amazing spot to look down at all the shows that are taking place at the Expo site. So we were happy to see people up there doing their picnics and relaxing. Also really a crucial point already during competition was the climate concept. We were working on this together with Transolar, also very impressive consultant from Stuttgart. So the idea was really how to create a synergy between the building's geometry, the construction method, and the ideas for conditioning. So the idea was to create this natural ventilation between the cones, and then also a thermal stratification of the air, so that you would only condition areas where people are really moving along, while other areas that are not that are very high up can be hot anyway. The kinetic facade, of course, is an integral part of this climate concept. So in its basic operation mode, it's providing shade and controlling solar input. But to us, it was at a very soon stage clear that we had the opportunity to create a completely new kind of media facade. Actually, the building is now in the new book by Hank Häusler, Häusler's media architecture, media facades, and we're the only building that we don't use LEDs, but we use the architecture itself. So the architectural layers themselves create the choreography and the movement. So this was also the idea that would be kind of a different media facade in a way. So of course we also have LEDs, because later on the clients developed that wish. So there were both ways. It was also working as a conventional media facade, but nevertheless it was also operating during day. After competition, still in shock that we have to build it now, we went to Stuttgart because we knew that we now really have to team up with the best. So we went to Knippers Helwig, who have a very impressive experience in kinematics, but also Professor Knippers is doing this amazing research in GFRP, and you're going to see, I think tomorrow or the day after, lots of papers of this really incredible research group. And so I don't want to go too much into detail about the biomimetics there, because it's also written in the paper, and we also published a book recently where Professor Knippers has written an essay. But just to briefly explain the principle, it's rather simple, like in this paper model here. You hold a strip of paper by 4 points, and by reducing the distance between two of them, the paper bends. So bending or torsional buckling is something that you usually want to prevent in architecture, and here we use it as a functional principle of the facade. So actually the blade itself is very thin. It's only 9 millimeters. It has a constant radius. It's all 17 meters, and it's just different in length, and of course in the build-up of the individual lamella. So here you see the lamella, you see the actuators on top and bottom that push the lamella, and on the right hand side you see the mock-up with the opened lamella. So you also see that the cross-section is L-shaped, so you have a stiffener on one side, that's also why it behaves differently. It's really, the movement comes out of the material behavior of the GFRP. So here you see the cross-sections to the lamella. Of course here there's the highest opening angle. A very beautiful continuous movement, as we think at least. And the other idea was also that we would implement light into the lamella, linear lights and on the inside, and that they would then create this embedded light effect. So to say, it would create really a synergy between geometry, light, and the material behavior of the facade. So, to give you some insights into fabrication, I hope. Sorry. Yeah. So, actually, although this seems to be a high-tech product, it is not at all. I think what's new is the new approach to it, the research, and the thinking, but the technology itself is rather old and known. And actually, it's a very simple, hands-on fabrication product going on here, as you can see. So it's these mats that are laid out and then combined with this resin, and it was produced in near Seoul by a firm called Ocho. And everything, as I mentioned before, had to take place at the same time. So they also built 3 of these negative forms. I mean, 1 would have been enough, but they had to speed up fabrication. And then while they were doing this on the outside, they were starting to test the lamellas in this prototype mock-up phase and also dealing with the programming. So all lamellas are fabricated in these molds and then cutted, and here you see the mock-up outside of the production hall. We've been testing 2 lamellas, the shortest and the longest ones, mainly to see the durability of it, especially of these parts where it is connected to the actuators. And actually, yeah, here you can see it moving now. So it's a spindle and connected to a servo motor, and these very tiny movements results in this very big opening of the lamella. So actually, it's a very efficient way of moving. There are little joints compared to mechanical solutions that would have many joints that also are many sources for failure. In this case, it's a very elegant solution, also very lightweight, of course. There were some issues with resonance, but they could be solved during the mock-up phase, and here you see. Yeah. So that was a fabrication, and then finally at the opening, the operation, so to say, at the sides. So each lamella can be individually operated. In this case, it's an opening to one side, but you could do all kinds of choreography. So the idea is really that the layers of the architecture itself becomes this 3-dimensional spatial experience, and you could also play with the lights of the interior spaces. And here, from further away, you see the effect of the opening and the closing again of the facade. So, as I believe, the movement or the effect without the cause is probably, without knowing the cause, is probably one of the strongest experiences still. And it was really beautiful to see that the visitors were standing in front of these 15-meter-long lamellas that were seamlessly opening, and they were applauding because they just didn't know how that worked, because there's no construction behind, and you could not tell from watching how it would work. So, yeah, I think from the previous lecture, I really would like to take this notion that architecture is in itself prototypical. I think that's very true, but I would like to add that doing prototypes is also this possibility of joining up with research, and in this case, I think it's really crucial to get this dialogue between research at universities, consultants, and architects. And I think we should not orientate at what's been out there or what's possible. We should rather focus on exploring what still can be done. So, close-up of the lamellas, and yeah. Now it's there, the eyes closed, so to say, and it's waiting for a new owner, and then for a new use, and hopefully for somebody who likes to play with it. So, who's interested? That's our book. I think it's also up there in the shop, and otherwise, yeah, questions are very welcome. Thanks for your attention.